My name is Michael Fuchs and I'm representing ABBYY here, and I would like to tell you a little bit about ScanPDF, about OCR, how it works, what we see as a challenge, where the technology goes to, and just also an explanation why OCR is not only character recognition. I will shortly introduce ABBYY because I'm in marketing, I cannot skip that. And I would like to give then a technical overview how OCR processing is done, so what's going on behind the scenes, and at the end cover some general topics, special scenarios where we see as a vendor of OCR technology where we're going to. There's the world in the background, so ABBYY's headquarters is in Moscow. All the core development of our technologies is done in Russia, and I'm working at ABBYY Europe. We're located in Munich, and we are in charge of the Western European countries, and there are other offices worldwide that deal with different regions. Yeah, that's it. So we are not developing core technologies in Munich, so we're just pipelining the requests to our developers in Moscow, and this is actually part of my position, so being between the customer needs, the developers, and also the sales marketing, so what we deliver. I will not do a product promotion here, but at least I would like to give you an overview that it is clear what we're talking about. So all ABBYY products have a core fundament of technologies. Overall, ABBYY's roots are not in OCR, ABBYY's roots are in linguistic technologies, and if you go to the Eastern European countries, ABBYY is well known as a dictionary provider and having a lot of linguistic technologies. Based on these core technologies, we provide software development kits. We have software development kits that run on Windows, Mac, Linux. We run on embedded systems. We run on mobile phones, supporting Android, iOS, Symbian, all these kind of things. And we're also going to the cloud. So we are offering OCR services in the cloud as a service, or we license technologies that enable our partners to run in the cloud. You can see the linguistics parts with SDK. It's currently empty, but this gap will be filled up soon, and you will see more and more technologies in the linguistic area coming from ABBYY in the near future. Based on top of our technologies and SDKs, ABBYY is also manufacturing end customer applications, and the end customers can be simple end users, desktop users. This is ABBYY FineReader. You might know it's bundled with a lot of scanners. It's a stripped down version. It's called FineReader Sprint. This actually helps us to get the brand awareness worldwide. We also have products for companies like ABBYY Recognition Server. So this is the server-based version of our technologies to do automated mass conversation of documents. And we have solutions around extracting information from documents, so invoice processing and other things, forms processing. So this is the flexi capture area. But at the end, mostly I will speak about the technologies offered in the core in our SDKs. So let's start how OCR actually works. And I was asked to make a technical representation. So I thought, okay, I start with a screenshot from the documentation. So this is the object model that comes with our FineReader engine on Windows. I will go through all of the points in detail, so it's not required that you have to read it here. No, just joking. I will cover only the main areas of that. So as you can see, it's 5 steps. It's from opening the images, pre-processing images, apply the character recognition, then verification is not the main part, it's just mentioned for completeness, and then it's about document synthesis and export. Andreas spoke already a lot about different image formats, so this is just for completeness. ABBYY technology can open a lot of different image formats. We can grab images from the memory of the computer. There's a Twain interface so that we can communicate with scanners. And we also have options, or we of course can process digital images that come from cameras and screen input, like for screen reading scenarios, for example. because we're talking about PDFs, I also made a separate slide on PDFs. So we're using actually Adobe's library to open PDFs. The reason for that is, in the very early days, our developers tried to write own code, but it was obviously clear we had the same issues. What is going on? I can't open the PDF. So we decided to have the most flexible tool on the market that can read the PDFs, because this is what the users expected. If any other viewer can open it, we are expected to have that as well. Of course, if a PDF is protected with passwords, we ask for the password, so we're not breaking that logic. If it is an image-only PDF, it's the processing that follows is actually what I will describe on the next slides. If we have a multi-page PDF or a multi-page TIFF, before we send it for processing, we split it into separate pages. So the internal format is actually an uncompressed bitmap. We have the thumbnail, we have the uncompressed bitmap, because we use this also as an interims format to save all the document analysis and recognition results. And it has changed over the technology generations, but currently it's an uncompressed bitmap, because this we saw that this has, it just works best. It's not the smallest solution, but since disk space is not that expensive anymore, it's possible to do. So, question right from the beginning. If you have a PDF that has an image in the text layer, question to you, would you trust the PDF layer?
Which layer?
The text layer in the PDF.
Define trust.
Sure. If you would just extract the text without ignoring the image, or would you just trash the text and just look for the image? What would you do?
What's the objective?
The objective is to find out if I have only an image or image PDF, okay, it is clear. So we process it like a regular image. But if the PDF already has some text in it, the question for us and for our developers and for the customers is, do we trust that text layer? And probably we do not know. So what the technology actually does, it runs document analysis, and it starts to apply OCR on a few characters. Then we get our OCR results, we have the Unicode stuff, and we just look in the text layer and see if the text is somehow matching to what we think it could be.
Okay.
We do this a few more characters. If that is promising, then we look on it on a line base, and we do this on multiple regions on the page. If that is fine, we actually use the text that is in the text layer. A lot of the times it's not usable. So this is the way how it's processed internally, just to clear this, or to explain this from the beginning. If we deal with images, and if we want to apply OCR, we have to do a lot of image pre-processing things to actually deliver the best recognition results. So first of all is automatic rotation of the image. So if you have a book that is 180 degrees, you cannot read it. The same applies to OCR. If it is skewed because it was scanned with a skew, you get much better result if you deskew the image. You can crop the images. If you put a book on the scanner, you have these curved lines in the middle of the book because you're not pressing that so hard. So for preparing the image to get the best recognition quality, it's better to split the image in the middle and then apply straightening text lines in the middle so that actually you have nice straight text lines. Also, we can do some color filtering, and based additionally to that, we can do noise removal, despeckling, and all these algorithms. That's clear because when you scan documents, especially in masses, you always have this dust from the scanning process on the paper. Of course, we can rotate in different angles as well. All these things are done automatically just to ensure the best recognition quality. The next thing is about image pre-processing in another way. The goal of our technologies is actually to get the text from the image. So the first thing we have to do is to get rid of the backgrounds. It can be a colorful background, it can be just a grayscale background. At the end, we want to have isolated text, as clear as possible. Also, if you look at that, if you have simple binarization processes, let's just say a threshold of 50%, and if you apply this to the image on the left side, you will lose 50% of the content. So that just will not work. So the technologies out of the box come with what we call adaptive binarization. So we do this on a region by region base to achieve the best results. Why is that so important? If you look here, you can see the text in the middle is okay. The characters are well separated. They're not broken apart. If you go down here, if you do binarization wrong, your characters break apart, and actually you cannot read it. The same, they get fatter and fatter and they're gluing together. That's also not what we want. So we actually need a rather good binary image. So this is also a common question. What does OCR want as an input? Yes, we can read binary image, but we would prefer to have a grayscale image because there is more digital meat on the bone and we can do the stuff ourselves. At the end, the character recognition is always executed on a binary image, even if you give us a color image. The color image is then, or the information from the color image is used when it's coming to the export part. And when you're interested in the color of a font or things like that. Here's just some examples of an original scan. The binarization we had up to technology version 9. And here is actually, you can see that you lose parts of the information here. And with version 10, which came out 1.5 years ago, we adjusted these kind of technologies actually to get much better result, to lose less contrast. So that's just a small part. As you can see here, this is very hard to read. Light gray background, white color space. So here you can see a little bit of it, but it's garbage in, garbage out, so it's not usable. But at the end, with the new approaches and new technologies our developers implemented, we do not lose any text even on these low contrast images here. The whole approach was also developed for a project. It was called Impact. It was a research project for digitalizing library materials. And there we have seen a lot of really bad quality images, and this is why this development started. And at the end, you will see that image quality has also an effect on processing speed. And with these image pre-processing optimizations, we were also at the end able to get faster processing because we have we use different classifiers for that. The next step is document analysis. If you have one page, the technology has to break it down and analyze it, what's on that page. So is it an image? Is it a barcode? Is it a text block? Is it a table? At the end, it finds the text blocks, it separates the text blocks to lines, it does the character segmentation, and the end goal of the image is you have different areas of your document page that actually then are sent for character recognition. Of course, if something goes wrong into this segmentation process, you have problems with the OCR results. So sometimes these things are readjusted during the recognition run automatically. There are different analysis modes for different scenarios. So our standard document analysis is done for layout reconstruction. So we actually do care where the text is located on the page. This is needed for PDF generation. This is needed for conversion to Office formats. If we go for a full text indexing scenario, we actually do not care so much about the layout. So we actually then would recognize text even on pictures that are as a natural scene image. And if it's readable, like the street sign of Basel, for example, then we would get this information as well, because actually we do not care about the layout. It's really extracting as much information, textual information from the image.
So you could wind up with a lot of garbage characters that way too.
Yes, of course. But the goal is actually to get most out of the document that you have. If it is garbage or not will be then given to the developers in terms of word in dictionary or usable characters or not.
So they post-process the text,
yeah,
and then go back and decide that the text from this zone was garbage because it came from the middle of the photograph?
Well, it could be. The technology does not know if it's garbage or not, because if you don't have the
well, your dictionary lookup fails.
Yeah. Then it's up to you as the developer. You can delete it. Out of the box, you will get the text.
Okay.
There's a third scenario, which is called document analysis for invoices. This is a special analysis mode for documents with big tables and text and numbers. And as you can see, it gives you different results on that. It's especially needed for business documents like invoices, invoice processing. This is why the name is done like that. Now we come to the next steps. We assume we have a good image. We have found all the text lines, and now we're going to the way how we read these different characters. Every OCR technology uses raster classifiers. So these are master pixel comparison things that are compared to the text that we need. Of course, ABBYY technology has that. Everyone does that. But this chart only highlights that there are much more options that are built in the technologies. For example, if we find different characters, we reduce them to a vector skeleton, because this at the end is size independent. We look at the contours just to see what the shape of the character looks like. There's experts who are able to distinguish between two very similar characters. In this example, it's the difference between the D and an O. Then you can see, if you would look at the right side, bottom top, there's no difference. You cannot see that here. But if you look at the bottom left and the bottom right, top right,
bottom left and top left.
Yeah, thanks. then it actually makes the difference. If you would put in a B, for example, you would have to look in the middle. So this is just, and there are up to 20 experts that are working on these different characters. So, and it's like here, you have a lot of experts in the room, and there can be hot discussions based what's the correct result or not. You will see there's an API for that you get access to this information. But before we present it to the developers, the technology also wants to know a little bit more about what it is processing. So we have different font types, because telling the technology if it is something printed in old fonts, Gothic Fraktur fonts, if it is a dot matrix thing, if it's typewritten, or a special OCR font, it really makes a big difference. So out of the box, we run it as the font type called normal, which covers more or less everything from normal printed documents, from inkjet printers, newspaper, magazines, because our technology is not optimized on a special font. It has this unified approach. So we only should know when we treat special characters, or we can expect them. Like if you do document conversion from an archive, you probably have typewritten stuff. If you have computer listings, you know that you have dot matrix stuff. You have to turn it on then. But if you're rather sure that it is normal material, just leave it normal fonts, then you get the best results. The next thing is about languages, because languages are printed in different alphabets. So in total we are almost at 200 supported languages now. These are spoken languages, but also artificial languages like C, C++, Pascal and other things, because they have a logical structure. Also there's a difference because we have, to make the OCR better, it's good to have a language definition, because if you have C or Pascal code, you know exactly what characters are allowed. So you can reduce that. The same applies if you have French text or English and German. In Germany we have umlauts. In English they're not allowed, and this actually influences the core recognition engine, because it says these characters are not allowed. Of course, we can process multiple languages at the same time. As a recommendation, please do not select more than 5 languages at the same time, because at the end the hypotheses go down. Because it might be a valid word in Turkish or in Turkmenish or whatever. So 3 is fine, up to 5 is okay, but if not, please do not select more. Just only for completeness, ABBYY has technologies to read handwritten forms. So this is called ICR, Intelligent Character Recognition, and we are also able to read check marks, like if you have survey forms or things like that. Should not be topic here. We're able to read barcodes, so most popular 1D and 2D barcodes. Also, it's not just the barcode reading, it's also finding these barcodes on the page. Some more features on that is the technology comes with what we call a voting API. So with this API, you can actually get the low-level information on this area you would like to read. This is used for, we call it field level or zonal scenarios. When you want to be really sure that the invoice number, because it's extremely critical, you can get, it's a word from dictionary, I think this is a D with 60% or with 80%. So you have all these type of information, and you can do database lookup or fuzzy lookups. For a full text scenario, nobody will do that work, but if you have just a small zone, you can have all this information. To make OCR better, at the end, we use also a lot of morphology dictionaries. This is why ABBYY's linguistic background is so important to get OCR quality. So we deliver standard dictionary. You can actually create your own dictionaries. You can give weights to words in these dictionaries. For special scenarios, we're able to have RAM dictionaries, so you can do really fast lookup during processing. And we also provide information about the font styles, about the formatting and all these kind of things that we actually find on the image. So we try also to say it's a serif font or it's non-serif font, all this information. If you need it, it is there. So in the SDK, there's of course an API for that. In other products, we have XML export that is able to produce really big XML outputs, but it contains all the information that you might need. Next step is about verification. Once we have run our document analysis, it is possible to involve the users to do layout checks or do text correction before you actually export. Of course, if you do mass conversion of archive materials or ongoing stuff, nobody will ever touch that. But if a publishing house wants to re-digitalize their content and materials, or we had requests from companies who have written their manuals in typewriters 20 years ago, and they want to go convert that to Word. So there it makes sense that even before you export the Word format or the searchable PDF, that somebody drops the images in a nice way, because we also have the problem Andreas mentioned. If there is no sharp edge of an image, it is better an operator just grabs that and does that. And here these visual components are part of the SDK. They can be used, and they automatically interact with the object that comes from our document analysis. So if you move the image rectangle, you will get it accordingly or changed automatically in the export file. Last step in the process is document synthesis and export. So this is just a list of different formats we can export. So of course we have all the image exports. We can simply export to text. Of course we support Unicode for all of the languages that we have. We can export to Office formats like Microsoft Office, or also OpenOffice. RTF is supported. We can do HTML exports. We can do XML in different variants. And of course we can do PDF. Recently we introduced EPUB and FP2. This is a ebook format used in Russia, or very popular there. Or Alto XML is a special format for libraries where they store the information of scanned library materials.
What do you guys do about composed characters in Unicode?
Ligatures?
No, composed. Well, ligatures is a related one, but I was thinking of composed characters, for example, in CJK or Thai or related languages, where it's the visual glyph is actually composed of multiple code, may be composed from multiple code points, and both are valid cases. Do you always do it one way? Is there a selectable determination as to which way to do it? I mean, simple, in Duff's example, even just like an FI ligature. Which way do you always write it out as the ligature, always as FI? Or? If
we detect it is a valid ligature, we try to do that, but otherwise we make the best guess. What we think it's most appropriate because of the analysis of if it is a word in dictionary or not. So sometimes at the end we also might mark it as uncertain because we have a flag that just says technology is not sure about that. So and the developer or even the user can see this uncertain recognized, or we classify it as uncertain. That might not be wrong, but we're not sure about that. What can we do in terms of PDF output? Yes, simple image PDFs. Then we can do linearized PDFs. We can do tag PDFs. This is part of the regular stuff since years. We can add the different security options like editing or password protection, all that stuff that is required. This is just screenshots from our product recognition server, but of course there's an API for that. In the past, as we've seen, that the PDF formats have grown and grown, and our list of parameters for PDF export has grown and grown as well. With version 10, we did some revamping of the API because we realized it's too complicated. 25 parameters is just too much. So our developers sat down and said, okay, we are going in different processing profiles. And for example, if you go for maximum processing speed or maximum PDF quality or minimum file size, you make it rather easy to select these different options. And additionally, there is a set of parameters where you can embed a font, where you can set the image resolutions and all these kind of things. So it's really, now we think it's rather simple to use, and that's actually what we also got as feedback from our developers. We also introduced in 9th technology MRC compression. Andreas explained the basic principles. We do it the same way, and yes, we use our analysis from the OCR results. Also, what is clear, it takes years of testing and finding out how to do it best. So there's also some improvements going on from technology to technology.
So you also put all images on the background layer?
I think so, yeah, but I do not know for sure. I have to check that. So it was interesting for me discussion, but I never had a question so far, but I will check for my interest. Okay. To make it easy for developers, we ship our SDKs with precompiled samples. So these are, it's just where you can load your own images, and it just does multiple runs with different of these profiles. So you can see image quality, maximum speed, file size, and at the same time it calculates the throughput on that machine, how many pages you can do per minute. So it gives you a rough estimation where you want to go. I will have more slides on processing speed later on. Yes, ABBYY is also a member of the PDFA Competence Center or PDF Association. We currently support PDF A1 and A and B, and PDF A2 is planned for the next major SDK, which is planned for Q4, which is then version 11. Okay, now, yeah, good in time. Some more words on some special tasks. We always get the question, processing quality, why is OCR so slow? So I think I tried to explain and give you some insights why this processing takes some time, because we operate on images, we clean images, there's a lot of hypotheses, a lot of mathematics in the background going on, and there's always this correlation if you go for quality or for speed. So yes, OCR is extremely CPU intense, and if Intel comes out with a new CPU, I can guarantee we always use it with 100%. And I've seen admins that saw our recognition server and all 5 or 4 cores were up to 100%. They actually thought there's something going wrong with the server. But it's just the way it works. Whatever is there, we use it. And quality and processing speed are on the opposite direction. So it's hard to get both. But quality normally does matter during the OCR process because it's applied only once in the lifetime of a document. So that's why at the end it is something. So here now I've got some slides here. The good news is there's a way out of that. So out of the box, ABBYY Technologies has different processing modes. So we have our normal mode, which is intended to be quality. We have a speed mode, which goes for maximum speed. And we have a balanced mode where the technology decides by themselves, it starts fast and falls back to normal if we see that it is not good enough. And this is an internal test slide on a test set, and you can see this is engine 8. This is the speed mode. It gives you around 20 pages per minute, and in quality mode it's maybe 15 or something. Then as you can see, technologies become faster and they become more accurate, even within one technology release. We have different, normally every 3 months we have a maintenance release. There are some changes in speed and quality because it's an ongoing optimization process. What happened with engine 10 is actually you can see that the speed mode actually got almost twice as fast. Why did this happen? Because we optimized the image pre-processing. So we got much better binarization stuff, and based on our tests we then selected a different class of classifiers and different kind of technology sets that actually gave us more or less the same quality level as had in the past, but optimized for speed. So this is, now we play the ball back to the users. We can say, okay, it's up to you. You can go in speed mode. If speed is most critical for you, then it's up to you. Or if you cannot decide, yeah, go to balance, then the technology is probably somewhere in between. And only if you have very low quality images like faxes, like other stuff, people know that, then we have a special low resolution mode, which delivers less errors on really bad quality images. On good quality images, you don't get any significant quality optimizations, but you're 20% slower. So the developers have actively turned on this high quality mode for low resolution images. So as you can see, we made processing on one core or on one machine actually more efficient. The other nice thing is actually the computers have more and more CPU cores, and we can utilize them. This is a test run we have done with recognition server on an 8-core machine, AMD, and also on a 16-core machine, Intel. So as you can see, it almost scales up linear, because if you have multiple documents to multiple pages, it's really separated out to different CPU cores. We're the smallest unit in our technology is on the page level. We've made some tests, but splitting up a page in processing doesn't bring us any further because it's too much overhead. So at least for the German-speaking guys that might know the CT, and they also did a test on how technologies scale up, and they actually said ABBYY is close to the optimum in terms of using most out of scalability. Also in the SDK, we have two different approaches to utilize these multiple cores. One is the document API. So if you have multi-page documents, you just process them and it automatically scales up to available cores. Or what we have is a batch processor. If you have a lot of single-page documents that are not related to each other, you just throw them in and you get them out. So and they're automatically scaled up. In previous versions of technology, developers had to write individual processes for that. And at the end, also we changed this is more or less a sales go-to-market strategy, is that we allow in certain license types to scale out in the network. So that's another way of scaling up if you have peaks or loads. So ABBYY is able to license volumes. So if you have X thousand pages per day or per month or per year, we do not care if you process it on one machine. The network license is a little bit more expensive, but then you can use everything that can calculate. So and also here, just with recognition server, it scales up almost linear. It's just the overhead of managing the files in the output formats.
You guys look at using the GPU for image processing?
No, at the moment. So we of course made some tests, but for all the processes, the overhead in splitting it up in small units is too much, because we cannot split up in regions. So with the new CPUs, we currently see no benefit of using GPUs for that. The next thing is about page analysis and document structure. So traditionally OCR, and I explained it works on one page, but often a document consists of multiple pages. So if you look at the book or a contract, there's a logical structure of the document. And starting with version 9, we introduced something called adaptive document recognition technology. And what it actually does, if you have a 10-page contract or a 100-page book, then normally every page is processed individually and exported separately. So it could happen that the headers and the footers and the page notes are somehow slightly different on all the pages. Now, with this new kind of technology, we compare all the different recognition results of all pages and see, okay, there's always something in the head of the document, and there's also something in the bottom left or right, and it looks like a number. So we assume actually it could be the footnote, or if you have different formattings of headlines over different pages. Sometimes it says it's Arial 10 or Arial 10 dot something. We assume, could be headline grade 1, grade 2, and we try to reconstruct the table of content. So on this thing, it's just what we currently can detect. So it's headlines, it is images, it's text inserts, and running titles and things like that. And not too many people use that or know about that this exists. We also offer a kind of API for that, where we give developers access to this kind of information. We think in the future it will be more and more important, especially when you convert to ebook scenarios, where people do not necessarily need the top layer, but you would like to understand the document. So what's inside for bookmarking, for adding metadata and all that stuff. So this is, technologies are in development for years now, and it's not so easy to just copy paste, because there are a lot of exceptions. Again, a lot of CPU time is needed, but actually it works rather good on standard documents. Of course, you can find thousands of documents where it doesn't work, but that's not the goal. So at least for contracts and stuff, it works rather good. Another way of going in is understanding documents is I call it full text OCR. This is what I explain to you now. First is data extraction. So if you have a document like that, and if you apply the standard layout analysis, it gives you, it tells you where the text blocks are, it tells you where an image are, or what a table is. That's fine, but imagine you want to extract only invoice numbers or the total of a document for indexing scenarios. So if you look in these two highlighted areas, so here you get all the text on the left side, because that's what full text OCR and document conversion is about. You should not lose that, but you decide if this information is relevant for you. And as you can see here, it's just the invoice number. And you want to have this, and you want to know exactly this is the invoice number, or this is the total of the invoice. And it's not just that I can reconstruct the table as a table to have it nicely layouted in Word, for example. You actually want to know what's the quantity, what's the description of the thing, what's the order number. So it's really understanding the logical structure of these documents. The technology we're using here, of course, as a developer, you can go low level, you get all the coordinates, you write very long and nice regular expressions. If you're a genius, it will work, yes. The problem is if your colleague is not a genius, he has no chance actually to maintain the whole stuff. So you really have to put a lot of efforts to make this technology work properly and also make the code in a way that is maintainable. So this is why ABBYY started to develop a technology that we call flexi layouts. It is actually a rule-based approach that does not only use the textual information, but it also uses the layout information. So for example, if you would like for an invoice number on a page, as a human, you would look for something that says invoice number, Rechnungsnummer, or whatever, but this is not what you're interested in. So you can specify, or you can say, I'm looking for something right of it, or below of it, which probably has between 5 and 20 characters, most likely between 10 and 20. It contains of characters. I allow only these type of characters, or I allow fuzzy characters as well. And it is on the top level, or on the top of the page. Or I'm looking for something like it says total, it's at the bottom of the page. So just by applying these kind of rules, the technology actually finds the areas based on these text fields you specify. Of course, these fields can be hard-coded, but they can from a database or from a text file. And at the end, the technology votes different hypotheses because some areas are missing on some kind of documents, and it actually gives you does all the work for you and gives you the best match and the best suggestion on these kind of things. And the goal is, of course, to have one flexi layout that works on a rather big set of semi-structured documents. So in reality, if you do invoice processing, you will probably have for your top 5 manufacturers dedicated flexi layouts and one general. But this technology is also good for document classification and separation, and I will talk about that later. Based on the same idea, it's about, in one of the other slides, I've seen the term redaction. So if I apply a flexi layout on a document, you can see I get the information in the way of different areas or the technology has detected, the information was read. So you as a developer have full access to that, but you might redact special information. It could be a credit card information that should not be stored in the searchable PDF. You might need it for the transaction, for the business process, but when you convert the whole document to a searchable PDF, you actually might redact that. And you should be redacted in the image layer, and it should be also removed in the text layer. So, and this is what at the end your stored or archived document might actually look like. For example, if you store patient records or laboratory tests, you might just X out all where the stuff comes from because it's not relevant or you're not allowed to store this information. And if you have this kind of semi-structured stuff, this technology does a lot of work for you that you don't have to code. Now we're almost at the end. It's about document separation. If somebody is doing scanning, normally if you have a flatbed scanner, that's not a topic you should consider, but if you have a production scanner where you put a pile of paper on and you scan that stuff, then you get something like that. So what was done here already was there are so-called separation sheets in the pile. So it's a piece of paper that has a patch code or a barcode or even a piece of text, and before it's put on the scanner, it's just laid in. and the technology can then use this information on the barcodes to separate these documents. These are screenshots from our scanning station that comes with recognition of our flexi capture, but also in the SDK it's not hard to code because you just cut the document stream or the page stream in pieces and process them as separate documents. So this is nice when you have a well-organized thing, and this is rather common sense. But the next thing is if you have kind of unstructured documents, and this is actually something where the flexi capture technology comes in place. What it does here is you can say here apply a special classifier flexi layout, and what this thing does is it knows how different document types are identified. So if you put into a flexi layout what the header of a document is and what the footer is, or if there is a logical structure of a document, like if you work for an insurance, there might be a 2-page cover sheet, and then for each individual another form, for example. You can set up these kind of document structures, and the technology will automatically identify them and separate them in a way. Also, at what you can see at the top, it says it's a price list, it's a letter, or it's an invoice. So it also does this kind of classification. And this technology has evolved. So when we introduced that in 2004-05, it was only able to process single-page documents, because at that time it was fine. Then with technology 8, we introduced multi-page support so that we can actually do the separation without this barcode stuff. And now with version 10 technologies, we extended that even further. So what we use is a combination of image-based classification. We can do some use some OCR, but only in big text blocks. Or at the end, we go to a full text rough OCR, where we do actually rules-based classification, what I said with the headers and footer stuff. Or we could even apply full text OCR on that and do content-based classification, so that you have your training set of different materials, and then actually the whole thing is done more or less automatically. Because if you classify an incoming document stream at the very beginning, it's much easier to process them. It's a letter or it's a contract or an invoice. You have to know that before. So different approaches, because here also it's about speed. And of course, image classification is much, much faster than applying OCR. But at the end, applying OCR on everything might just take too long for some customers. And it's really up to you or to the developers, to the business needs, what type of classification then is used. So that was just a rough overview how OCR works, what we actually currently are doing, what we're working on. So are there any more questions? Yeah?
I have two questions related to customer requests. You mentioned that you are able to create tag PDF.
Yeah.
And the tags are based on an intelligent, automatic structure recognition.
Yeah.
Is there anywhere in your process the opportunity to modify those tags?
Yeah, actually, this is
some kind of editor. So
yeah,
there are sure mistakes during the
yeah. This is where the visual components come in, because there's an API that says this is the different order of the text blocks, but in the user interface, in the visual components, you can actually, there's a tool for that, and you can say this is 1, 2, 3, 4, 5. So the user can actually change the text order, and then after this was changed, it's exported that way.
And can you open an existing PDF and edit that, or is it always part of the process?
That's always part of the process, because we actually have to run our document analysis. And what I said at the beginning, we try to compare with the original text, but what we actually need for our stuff is to apply our own document recognition technology.
Okay, so you cannot edit an existing
no.
PDF?
Without applying the analysis. And if the text layer fits the image on top, we do not apply OCR, in theory. And then the user can justify that, because at the end, we use Adobe technology to open PDFs to access the metadata, but all the export part is based on the internal ABBYY format, and all the export routines are coming directly from ABBYY, because we rely on our internal analysis and export or logic of our document structure.
So in other words, you'd have to rasterize your PDF in order to get your software to do anything with it.
Yes.
In worst case, yes. That's currently, if there is a way, and this is where I'm looking at the market, yes, of course, I know it's the brute force way to do it. But what I know is, especially when it comes to business processes and invoice processing, that's what a lot of companies do. They just TIFF the stuff, because then it's one single entry source and getting the classification done. It's because you cannot always trust what's in the text layer. We discussed this, that if the characters are too far away, there might be a blank, it's not recognized as a word, or the sample we have seen in the morning in the 7 minutes presentation that the text order is not correct. We know that even some companies want or use OCR to get the text flow back to Office, because some users want re-editable documents or text in the right order. So this is where the technology is used as well. If there is technology out in the market that could transfer these textual images to our internal, I'm happy to discuss with you and see what we can work together on. Because it's important, yes, but in some areas that's the way it works at the moment.
So you can control the text order, but can you control the type of structure that you create? I mean, you mentioned that you can say, I want to read this first, but can you tag it? Can you say, no, this shouldn't be a table?
Yeah. Of course, you have the API. So normally the standard procedure is you open the document, you apply the document analysis with the different options. Even if you do not apply it, you have the full API to draw your areas by yourself. So if you know exactly what you're looking for on certain types of document, you can skip that process. So you can draw one big text area and just say read it, and then you will get the text just what it finds automatically. So you have full control over that.
On the type of tag as well? So whether it's a heading 1 or a heading 2?
No, this is just if you draw it by yourself, because we rely on the comparison of the multiple pages, and but it's if you do your own estimations, you just set that. Or
so does that mean that all the tags you write out are paragraph tags?
No, actually not, because if it's a multi-page text, depending on the output format, it is a 2-column text in Word, for example. So it's not, we have different, especially when we export to Word, we have a mode that is called as close to the original. Then we really draw text blocks and paragraphs, and if you edit that, it doesn't go to the other column. But if you switch to the mode that says editable copy, we're not sticking so close to what the original format was, so we try to come as close as possible, but then the text flow is one multi-column text, for example.
Okay. I was actually referring to tagged PDF output. So there are different tag types: paragraph, heading, list, table.
That's out of the box. So as we depend it, or you change it via the API.
Okay.
Good. 3 minutes left. I'm so proud that I did it in time. So if you have any questions, just speak to me, or the way you can test, or if somebody has not tested the ABBYY SDKs, the way it works normally from a business point of view, you sign a trial license agreement and you get a full version of the SDK, 60 days, it's just a limited number of pages, and then you have the full access. You can evaluate that. There are pre-compiled samples coming with that. So you just can have a look at that and then just look at the API and on the codes, and that's what you can do. Okay, thank you for your attention.